Here we are in Lab 2, Projectile Motion. Intro to this lab. The purpose of the lab to create a code that mimics real-life observed projectile data. To do this, apply the position, or a time to position and a velocity graph using Newton's laws, velocity and position update formula. And these are the graphs of position to time. What's what? In the experiment, the system is a paper ball, and the surrounding forces are drag, air resistance, and gravity. The movement starts with my group mates shooting a paper ball like basketball. How do we get position and velocity? To find the initial force, velocity, and position, use tracker with the video of my group. Use to pull out data. The vector with the initial, or the vector with initial value or position, that, and a constant f net vector. And then velocity, initial velocity was 0. Since force is constant, I would use V average instead of V final. What did I do? My code involved the use of the velocity update formula. V final equals V initial plus F net divided by mass times delta T. And the position update formula, which equals R final plus R final equals R initial plus V average times delta T. And since the force constant, it doesn't change. The initial time of the video is 2.4 seconds. Delta T starts at 0.01 second and increases by 0.01 seconds every time the position is updated until time equals 2.7 seconds. I use position update formula, position update and velocity update in a loop, but using two different codes because one included a drag force and the other one was just the force of gravity. This is the code involving drag force, which would be the B right here, but I didn't include it in the screenshot. So this one is without drag force. And discussion in regards to what the plots look like. They simulated the real world data. Velocity didn't change, stay constant because the force was equal to 0, and the position had a linear increase because in the x component. My graph with drag force predicted terminal velocity, while the graph with out drag force didn't. Some possible errors could be the calculations by tracker, which if they were different, all the data points would change. And if the paper ball were thrown straight up, it would take longer to hit the ground because we use variables of T up and T down and T total. Then T total will equal initial velocity over G. And if drag force is included, the acceleration be slowed down, which means it'll take longer for the paper ball to hit the ground.